Hello everybody, welcome to our third video as we review for the big bear that we call the midterm. And today I got 5 doozies for you to check out. And before you hit the pause button, let's do a brief overview here. We're going to kickstart things with a nice logarithmic equation here. We'll see if you can condense the terms and solve for x. Number 2, we're gonna look at some inverse variation here. We're looking at 2 variables that vary inversely. So feel free to look in your notebook, find the formula that you want to kind of start things off with there, and I think if we look it up in our notebook, we'll have a better chance of it sticking in our minds for tomorrow. Number 3, we're going to look at an inequality. Not just any inequality, but you'll notice because of that first term, it's a quadratic inequality. Number 4, we're going to try to graph this exponential equation here, and I would say let's be safe and go with at least 5 points. We'll plot at least 5 points, and then we're going to write the equation of its asymptote. And then last but not least, we're going to multiply this binomial, and I'll let you interpret what you want to do with that squared sign. So go ahead, hit the review, and let's challenge yourself and see if we can go 5 for 5 today. As I get ready to attack this logarithmic equation, what I'm going to do is I'm going to use my product rule in order to condense these 2 terms together into one logarithmic term. So we're using the product rule, and that's to condense. So here's what's going to happen. I'm going to have one log. The base is still going to be the quantity x plus 3, but what am I taking the log of? It's going to be the product of this term and this term here. So I'm going to do some foiling in my head. I'm going to get 2x squared, and my outer is 10x, inner is 3x for a grand total of 13x, and my last is going to be 15, and that's equal to 2. My next move here is I want to convert it from logarithmic into exponential. How do we do that? We use a method called around the world. So let's see, what does around the world look like? Around the world says I'm going to start with this base right here. I'm going to raise it to the second power and then set it equal to this quantity right here. So we've got x plus 3 raised to the second power equals 2x squared plus 13x plus 15. Okay, now this squared sign is going to tell us to FOIL out the x plus 3. So we get x squared plus 6x plus 9 equals that 2x squared plus 13x plus 5. And now I'm going to try to move all the terms to one side, in other words, set it equal to 0. If I subtract an x squared from 2x squared, I get 1x squared. Subtract 6x from 13x, and I'll get 7x. And I'm subtract 9 from the 15 to get a 6. Oh, sweet Jesus, it's going to factor real nice. Look at that, x plus 6, x plus 1. Tee that bear up, and we're going to get x equals negative 6 as a potential solution, and x equals negative 1. And of course, those are potential solutions. Here's what we got to do. We got to make sure that the inner functions are positive up here in the original one. And here's the trick. Everything's got to be positive. So this quantity's got to be positive, and this quantity's going to be positive. So let's take the negative 6, for instance. If I substitute the negative 6 right here, by the time I add 3, it's still going to be, it's going to give me negative 3. And because it's a negative result, I'm going to reject the negative 6, okay? So right off the bat. Now let's take negative 1. Substitute negative 1. If I add the 3, it turns out to be positive there. If I substitute a negative 1 here, it ends up being positive. And if I substitute negative 1 there, it ends up being positive. So I think negative 1 is going to work, although I did reject the negative 6. Final solution, negative 1. Alright, our second problem is all about inverse variation. 2 quantities. Usually we would say x and y vary inversely with one another. So anyway, the formula that we found in our notebook says y is equal to k divided by x. And my first objective is always to try to find the value of k. So real quick here, and you wouldn't necessarily have to write this on your test, but just clarification, I'm going to say price per person is my y. And I'll just define that right here, price per person. And then, let's see, what's the other variable here? It looks like number of passengers is going to be my x. So we're going to let x represent the number of passengers in the limo. Kind of a fun question to think about. Problem is not that far away. It's coming around the corner before you know it. So what I'm going to do is I'm going to substitute the 5 for x, and I'm going to substitute the 70 in for y. And what that's going to do is that's going to help me find k, because it's all about, just keep telling yourself, it's all about finding k first. If I cross multiply, I'll get 350 equals k. So that tells me I'm halfway home. Alright, so I'm going to rewrite the equation up here, and I'll say y is equal to 350 divided by x. All I did is just substituted that 350 in for k, now that I know what it is. And we're going to go finish this one up. They said, well, how many people, so that means x is going to be the unknown, were in the limousine when the cost was $87.50. So I'm going to substitute that $87.50 for y. $87.50 equals 350 divided by x. Again, we'll cross multiply. $87.50 times x equals 350. Divide both sides by $87.50, and x is going to be 4 passengers. So we say 4 passengers in the limo, they each paid $87.50. Real quick overview here is when we're working with a quadratic inequality, my big game plan is to try to find the critical points. What we're going to do is we're going to put those critical points on a number line, and then we're going to test each interval to see which one's true versus which one's false. Then we can shade in the true intervals. So that's kind of a brief overview. First things first, let's get this quadratic in standard form. In other words, we're going to subtract the 5 over. And if you recall in your notes, we basically said we're going to, for intensive purposes right now, we're going to treat it like an equation rather than an inequality. And we're just going to try to factor this one. And for now, we're going to pretend it's equal to 0. We're going to tee it up, and we're going to get x equals 5 as a solution, x equals -1. And what we're going to do is, we said we're going to put those critical points, we'll call 5 a critical point, we'll call the -1. We're going to put them on a number line. The next thing I'm going to do is I'm going to pick a number such as negative, we'll say 5. And what I'm going to do is I'm going to test -5 to see if it's true or false. And I'm going to plug it into the original right here. So I'll show a little bit of scrap work here. -5 squared minus 4 times -5 greater than 5. Let's see, that turns out to be 25 plus 20. Is that greater than 5? I think yes, that's definitely true. The next thing I'm going to do is I'm going to test a 0, just because it falls between -1 and 5. Again, I'm going to plug it into the original here. We got 0 squared minus 4 times 0 greater than 5. 0 minus 0 greater than 5. That's a big false. That is definitely not true. And then last but not least, something bigger than 5, I'm going to go with 10, just because it's an easy number for me to crunch. So substitute it into the original. And let's see, 100 minus 40, is that greater than 5? Definitely. 60 is definitely greater than 5. So what I'm going to do is, notice the inequality sign did not have an equals component to it, so we're going to go open circle, shade towards the true, shade towards the true. And then if we had to write our solution algebraically, I would say something like all x values less than -1 or all x values greater than 5. And that would be my algebraic solution to accompany the graphical solution we had right here. Our fourth question is we wanted to graph this exponential function 2 raised to the power of x minus 1 minus 4. Just be really careful when you type it in to make sure the x minus 1 is part of the exponent. If you do have a TI-83, we'll have to put a special set of parentheses around that quantity up there. And on my table, I wrote down more numbers than I might normally write down just to help us out. And if you're having trouble identifying the asymptote, which is something I encourage you to do first before you do anything else, is look at the pattern in these y values. As you go up the table here, and you could go even further on your calculator screen, just ask yourself, what are these numbers getting closer and closer to? And I think you'll notice the pattern that these are getting closer and closer to -4. So that tells me right off the bat that I've got an asymptote at y equals -4. Okay, and that's the first thing I'm going to put on my graph. And I would encourage you to try to get in the same habit of graphing that before you worry about anything else. The next thing we'll do is I'm just going to start to plot points. Like we said, I'm going to shoot for 5 of the friendliest points that I think are the easiest. And then watch, once I plot these points, I want you to make sure you extend your graph infinitely to the left and infinitely up and to the right. So here, I just took a second to plot a bunch of the points that I thought were the friendliest. They obviously get harder and harder. So what I'm going to do is here is I'm going to extend my graph. I'm going to be very careful to try not to touch the asymptote. And let's see, then it's going to rise real rapidly. And so I'm just using all of the graph paper and extending my graph infinitely to the left in this region. Like for instance, you wouldn't want to stop right here. You want to continue to draw that graph all the way across. And then I extended infinitely high as well until I went right off the paper. Alright, our last one here, they wanted us to multiply, and as soon as I saw the squared sign, I was thinking FOIL. So the one thing that I like to do is I just like to rewrite the binomials. Whoops, scratch that. I don't want that parenthesis yet. X over 5 minus 3/4 times itself. And I'm going to go in ultra slow motion here, just in case we're having any trouble at all. You'll feel a lot better by the time we're done. Let's say first times first. So that's x over 5 times x over 5. Then we'll come back and talk about that there in a second. Outside means we've got to multiply those two terms. So I've got x over 5 times negative 3/4. I just like to move the negative right to the numerator there. Inside terms, so I've got a negative 3/4 times x over 5. And then last two terms there. So I've got a negative 3/4 times another negative 3/4. You know, and certainly if you feel comfortable multiplying those fractions in your head right off the bat, you can skip this step that I'm showing you right now, but I think it's beneficial at the same time. So let's see here. If I multiplied these first two fractions together, and again, we're going straight across, so numerator times numerator gives me a product of x squared, and denominator times denominator gives me a product of 25. Next term here, let's multiply these two rascals. Numerator is negative 3x. Denominator is a 20. Let's see, multiply these two guys. I love square brackets. It just kind of helps me organize my thoughts. Multiply the numerators, negative 3x. And the denominators give me a product of 20. And then last but not least, we'll get those two guys. And I'm thinking positive 9 over 16. Take a step back and ask yourself if there's any like terms you can combine. And I think we can combine these two middle terms right here because we have common denominators, luckily, and they're like terms. So I'm thinking minus 6x over 20 plus 9/16. And that, ladies and gentlemen, is my final answer. So that does it for our 3 videos on reviewing for the midterm. I think you're going to hit the ball right out of the park tomorrow, and good luck.